Okay, 6A part 1. I'm surprised that a lot of you did not get this correct. 1 mark definition question. So the correct word to use should be species. A lot of you write substance, element. I just cancel for you and write the word species because it should be a generic sounding term. Okay, and I must see the word simultaneously. Or in place of simultaneous or simultaneously, you can write at the same time. Otherwise, you will not get the 1 mark. So please go and memorize. It's as simple as that. Next one. Whenever they ask you to write half equations, right? Can you please remember, do not put reversible arrows. Because once you state something is oxidation and reduction, the direction is fixed. So once I see reversible arrows straight away, I will give wrong, okay? Now, another thing you must pay attention to for this question is alkaline medium. So in order to get the full 2 marks, the oxidation, reduction, as well as the overall equation must be perfect in order to get the full 2 marks. Some of you, the oxidation, you give me H+. That's where you get marks deducted, right? Because the question clearly states alkaline, right? But some of you gave me oxidation and reduction, but your overall was wrong because you never simplify. So I sympathize you. I will ignore you never take note of the alkaline condition, okay? This one, I've got a lot of things to say. I'm amazed by your lack of knowledge, which is, I'm trying to sound nice. So without the use of other reagent and chemicals means you are not allowed to use aqueous silver nitrate, which means your white PPT, cream PPT, and yellow PPT answer should not appear on this script. Now, I get a lot of funny answers because I don't know where you read from. You think that displacement reaction can only work when you use chlorine gas passed into the solution containing I- and Br-. So in the answer, I see what electrolyze the Cl2 in water to get pure chlorine gas. After that, I pass the chlorine gas into the bottle E and F. No need, just mix D with E or D with F, okay? And I am also amazed that you do not bother to go and use your dear data booklet, which I have print screen and put on the slide. Can you see for yourself? Aqueous solution, bromine is brown. It's not, sorry, bromine is orange. I2 is brown in aqueous solution. I highlighted in green for you. So if you cannot memorize well or your brain is not very alert on a day, right? If you have data booklet, please use data booklet, okay? So the common mistake I get is when you have iodine produced in water, right? I will also expect to see black PPT because iodine is not very soluble in water. So you should get brown solution with black PPT. Go and look at your notes. We also put brown solution with black PPT, okay? A lot of you waste your time giving me the calculation for E0 cell, which is not necessary because they never say what use relevant information from data booklet to explain your answer. All those no need. I just need to see the observation with the correct balance equation. That's all. Next one, also quite atrocious. You all don't know what is 1 bar. So in your calculation, the 1 bar, I see 101325. Again, I copy and paste from your data booklet highlighted in green for you as well. Can see for yourself or not? 1 bar is 1 times 10 to the power of 5 Pascal. 1 ATM then is 101325. Why do you make such mistake? When the data booklet is staring at you, the data booklet is trying to say, use me, but you ignore him or her. Walao, how can that be? Okay, just to highlight another point, RTP for your syllabus is no longer 298 Kelvin. I highlighted for you there because I cannot trust your memory. It's 293. You means you have not been looking at your data booklet. Can go and see for yourself now. RTP is not 298, it's 293. Go and see for yourself, okay? Don't say I bullshit you. So you apply PV, got nRT. Your volume must be in meter cube. A lot of conversion mistakes here, so please go and brush up. Okay, done. This question. In order for you to get the mark, you must say that chlorine gas is not an ideal gas. That's why I put it in red. After that, then you tell me, oh, there are significant intermolecular forces of attraction between gaseous particles, or you use the volume argument. That means the gas particles do occupy a volume relative to the size of the container, okay? Next one, calculation question, Mohs and stoichiometry question. To do this type of question, right, you must be aware of the story of know what is happening. So the story I write in blue. So your BrOX minus will oxidize I minus to I2. And they tell you that excess of I minus is used. So that means all the BrOX minus will be reacted away. After that, the I2 that is produced by the bullet point number 1 will be reduced by your S2O32 minus. Now, in your Mohs and stoichiometry notes, right, reaction of S2O32 minus and I2 is something you need to memorize. Okay, it's stated in the learning outcome. So you must be able to produce that balance equation that I show you. So why do I write the 2 in red? Because a lot of you do not know the mole ratio. That's why in your calculation, I did not get 0.00990. In fact, I get 0.0198 because you don't know the mole ratio of 2:1. So if you get the balance equation, you should be able to get 0.00990 moles. Okay. Now, after you have gotten 0.00990, you will be able to get the answer because your I2 and I minus is related by 2:1, right? As well as the number of moles of electron, 2:1. So you times 2 first. And the question clearly says to the nearest integer. So if you never change your final answer to 2, you also not get the marks. Okay?
Okay, next question. This one also atrocious. Why? I think 50% of the students did not identify for me. Okay, which is the cream PPT and which is the yellow PPT? All of you got the correct answer, yes. But such questions ask you for identities, guys. So please label it correctly. Which is the cream PPT, which is the yellow PPT, all right? Very common mistakes, huh? Some gave the wrong PPT. Up till now, you're saying that cream PPT is AgCl. What's the color of AgCl, guys? White, okay? Some gave funny answers like NaBr as well. No, it's aqueous, there's no PPT form. Okay, let's move on. Part 4. Now determine the oxidation number of bromine in BrOX minus, and hence deduce the value of X. Okay, we have given you the first part of the answer. If you don't really understand, okay, how to do this? I've given you another approach, which is the one in the bottom. So you understand that BrOX, one molecule of that, one mole of that, actually gain 2 moles of electrons to form Br minus. So first, let N be the oxidation state of Br in BrOX minus. Okay, we can do that. So now we know that the oxidation state of oxygen atom did not change at all. It is a Br that has gained the electrons to be reduced to -1. So formal equation, N minus 2 equals to -1. Therefore, first, you already know that the oxidation state of bromine is actually a positive one from here. Okay? Then from there, solve for X. How do you do that? just substitute N. I'm at step 4 right now. Okay, over here, see where my cursor is, plus 1 minus 2x. Minus 2 is the charge of oxygen, right? So negative 2x equals to negative 1. Therefore, x equals to 1. Okay, this is the approach. Now, you might be thinking, teacher, I wrote the correct answers and how come I only get 1? According to Cambridge, I pull out the glossary of terms for you guys. The word determine means that you need to obtain the answer via calculation. So if the first part you did not calculate at all, you just tell me the oxidation state of bromine in BrOX minus is actually a +1, I cannot give you the mark because determine this word requires calculation from you. Okay, at the very least, you need to tell me this sentence that BrOX minus gain 2 electrons from Br minus this part, so that I can make out how you actually arrive the oxidation state of Br. Okay, next deduce the value. Okay, then you can state the value. Yeah, I hope this is clear. Let's move on. Part C. This question also not very well done. Okay, I think majority didn't score this. Draw the dot and cross diagram of calcium iodate. Firstly, before you even start considering what the dot and cross diagram is, you have to first find out what's the charge of the iodate, right? Okay, so based on your O-level knowledge, you should know that iodate, okay, to balance out the charges, each iodate, IO3, should have a -1 charge. That's the bare minimum that you should go. All right, next, this is the answer given to you. I'm going to do a step-by-step approach. Firstly, how do you get calcium 2 plus, of course, is from group 2, right? So you know that calcium metal is going to lose the 2 valence electrons to the iodate. So let's do this step by step. These are all from your notes. How do you approach this? So first, consider which one is a central atom. I have many people telling me that, okay, there are some weird answers like oxygen is a central atom, or like there's sharing between the 2 i's. So please be very careful. Okay, so usually the central atom is the one with the fewer number of atoms. So iodine is in the middle. Next, where does the electron that has been lost by Ca2 plus, where is it going to lie? Which atom in this polyatomic ion? Okay, see where I've highlighted this particular anion that has the most electronegative element, it will gain the electron. Therefore, I put the extra electron that has been gained from Ca2 plus over here at oxygen. Okay, this is my first step. Second step, let's consider. Okay, look at where my cursor is. Next, ensure that the surrounding atoms they achieve octet. All right, so all your oxygen must achieve the octet configuration, which is valence electrons of 8. Therefore, okay, you start to fill up because it's in group 16. So each of these 2 oxygen atoms, it will share 2 electrons with iodine. That's how you piece up the double bond for these 2 oxygen. All right, but the oxygen atom at the top is already gained that 1 electron. To achieve octet, it just needs to share 1 more with iodine. So this is how you get the dot and cross. Lastly, all right, count the number of electrons in the central atom. Make sure that all the electrons in iodine is accounted for. You'll notice that it has 1 lone pair of electrons over here. And the very last stage, consider whether the central atom can expand its octet. It can, because iodine is in period 5. So it doesn't follow the octet rule. All right. So this is how you get your final answer here. These are the common mistakes. There is no need to draw the full valence electron shell on the cations. No need. Please bear in mind. Okay, because you're losing the electrons to your anions. No need to draw. Okay. Second mistake is that a lot of y'all draw a dative bond between I and O, thinking that, okay, there must be a dative bond. There's no need. Why? Your iodine is beyond period 3, is at period 5. There's an ability to expand the octet. So doesn't follow octet rule. And third, between I and O. So some of y'all actually place the additional electron on iodine instead, which is wrong. Okay, because oxygen is more electronegative. So I hope that this approach is clear to you. Okay, let's move on. Okay, part 2, nothing to say, nothing much to say. This question already asked you to include state symbols. A lot of you didn't include. Okay, so that one is on you. Next, I still have unbalanced equations. You need to count the atoms properly. And third, guys, in the question itself, they tell you that the state of the iodine is in gaseous form already. It's not solid. So please be very careful over here. It's in gaseous state. Because they tell you a violet gas. So you in gaseous form, iodine is actually colored, it's violet. So you need to deduce that to yourself. Okay, let's move on. Now, this question, can I have your attention, please? This is a 4-mark question, so I want you all to pay attention on the approach of this question. All right. So this question, they are telling you that GH and J, they are group 2 metals. You have calcium, strontium, and barium. They are not in the same order. And these are the graphs showing the change in mass. So you have 2 grams. You begin with 2 grams, and they are all heated separately at T degrees Celsius, right? We let it run. Now, they ask you to identify what is GH and J, explain the answer using information. Now, you've got to tell us what you observe. Okay, I'm at point number 1 right now. Most of you say that there's no change in mass. And then you deduce that HiO3, H-iodate is the most thermally stable. However, I tell you that this is not an accurate observation because no change in mass. What can you deduce out of it? Is that thermal decomposition? No, right? So you got to tell us from the graph. This is the information that you get from the graph. There's no change in mass. It does not undergo thermal decom. That is one thing. Okay? So a lot of you, I think 50% of you didn't write this. Second, the most common observation is that you compare across the graph. What you did was that you compare the decrease in mass of the iodates is the greatest for J iodate. Okay, because of the decrease 1.71 grams as compared to G iodate. Therefore, you say that the thermal decomposition in J is actually the greatest. Therefore, you conclude this too. No. Why? Okay, listen up. Look at the question step. This is the assumption that you have made that the graph is drawn to scale and the reaction has run to full completion. Not true. They did not tell you that the graph, that the thermal decomposition has been run, okay, fully. So you cannot assume that the time taken for, let's say, G iodate to achieve 0.47 grams is the same as the time taken for J to achieve 0.29. You cannot assume that the thermal decomposition has been run to full completion. This is what I'm saying. So you cannot assume that the graph is drawn to scale. It's not true. So how do we counter that? All right. How do we explain your answer? Okay. This answer given to you, I'm gonna do a step-by-step approach. So the first part, I think most of you identified G, H, and J correctly. Okay, so I'm not going to go through. So G is strontium, H is barium, J is calcium. Each of this, if you identify correctly, there will be a tick. Second, okay, to justify H, right? We use your theory. So your story about barium 2+ is the largest, having the lowest charge density, your marks will be considered here. All right. Resulting in the least polarizing. IO bonds is weakened to a smallest extent. Okay, bonds are broken least easily. It does not undergo thermal decomposition. Now, how then can we justify the identity of G and H? You have to justify within the graph itself. How do we do that? You have learned that the thermal decomposition of iodate, look at where my cursor is. Okay, when it decomposes, it will form GO, the oxide, and then the rest of it will be escaped as a gas. So what you know that is that the start, before the thermal decomposition, you have the iodate. At the end, what you're left with is the oxide. So what you can do here is you can do calculations to justify the identity of G within the graph itself. Because 1 mole of iodate will produce 1 mole of the oxide. Therefore, if you let the relative atomic mass of G to be X, you can form equations over here. You take the initial mass divided by the MR, okay, including X as a AR, you'll get this amount of moles. Similarly, number of moles of GO, you take what is remaining 0.47, you divide by the MR of GO. You let X be the relative atomic mass. Okay, since this is 1:1 mole ratio, you calculate X. So you'll find that, okay, this particular AR, it belongs to strontium. This is how you justify for G. You can do the same for J actually, for calcium. All right, using its graph. Okay, this is how you do it. So don't compare a cross graph because the graph is not drawn to scale. Okay, I hope this is clear. Now, what are the common errors? A lot of y'all mentioned this. You'll just use your theory and justify the entire thing, right? Why do you not get the tick? Because a lot of y'all just say that, oh, group 2 iodides is increasingly more stable. You didn't tell me the sequence of metal down the group. So down the group, you're gonna tell me the sequence of the metals. If not, it's a guessing game for me. Okay, that's the first point. Second point, like I mentioned, assumption is that the graph is drawn to scale, not true. Okay. Third, a lot of y'all make this mistake, guys. Okay, when you're talking about charge density, you have to identify the ionic radius, not atomic radius of barium. Not barium metal, but barium 2 plus. Because we're talking about ionic radius over here. Be very specific. Check your wordings. Okay, so ionic radius is the largest, hence charge density of Ba2 plus. Okay, is the smallest. Fourth error. Down the group, nuclear charge of metal ions remains the same. Not true, right? Guys, what is nuclear charge? Number of protons. So down the group, the charge of metal ions. I think this is what you want to say. The charge remains at +2, not nuclear charge. And finally, some of you all mentioned about lattice energy between barium and IO3 minus is the largest. Wrong concept here. You got to identify that IO3 minus has a very large electron cloud that can be polarized by group 2 metals. Okay? So hope this is clear for you guys. So that's all for question 6. There we get stuck.